Good evening. I hope I'm audible. If anyone can tell me I am, then that would be great. Okay, let's get started. And hopefully my VS Code is showing up for everyone, so we can begin. Last time we left off, we had Bazel and Recc working successfully against casplay. And my thought for today was that it would be nice to make it so that casplay wasn't just an in-memory storage system. We could perhaps add file system backend and maybe even remote CAS storage so that we can make something happen. Hi, Slayer. So the other day I spent some time and I wrote a trait for storage, for a storage backend, which is available on the GitHub. And here it is. In particular, the three functions start, read, start, write, and contains have to be implemented in order that a storage backend works. Batch update blobs, batch read blobs, and find missing blobs have default implementations, but we can specialize them for particularly the remote CAS, since we may as well just kind of send it all through. And there's also a trait for a write session, because receiving a write obviously involves starting it and then processing blocks that come out of the stream from the client, and then finishing the write and double checking the digest at that point. So I've also written a trivial memory storage backend. This is basically exactly the storage that we currently have in the server. So it's a hash map from digest to arc slice of U8, and it starts off life with the empty digest in it as well. So with all that in place, there's the implementation of write block and finish for the writer, and then starting a write just involves creating a writer. Starting a read, well, it's one great big long process chain there, but the main thing is that we spawn a sender task and then give you back a receiver stream, just like again we did in the main server code before. And contains is trivially lock the content and check if the digest is present. I've even written some tests for these because, well, I wasn't going to integrate it into the main server code without you all, so I thought I would do this. So step one for us is going to be to change over our server code here so that instead of having, let me find it, instead of having this present in the CAS server object, instead we have a storage backend, and then we can use that instead. So let's begin by starting to hack on all of that. Where are we going to get going? Well, at the moment we initiate start a CAS server like that, so we probably want to go storage is let's go for memory storage instantiate, and you'll see that Rust Analyzer tells us this is a boxed in storage backend. And the reason that I've decided that these things should always be type erased is because I don't want you faffing about with these things in any way that isn't completely safe. And at the moment, that's entirely through the storage backend trait, so that's that. Later, we might look into ways to not have to constantly type erase things, but for now, I'm quite happy with that. So we're going to pass in not only the instance name, but we're also going to pass in the storage. And now, of course, that's not expected. So let's come down here. And as well as the instance name, we're going to have a storage, which is a storage backend instance. We'll need to store that. So let's have a storage here. And we can stick the storage in. So trivially, we've initialized the content. Now, obviously, we're not currently reading from it. So let's have a see. let's get rid of content so that everything stops compiling and find out where we can get to from there. So we can't preload content with the empty object because we can't. So I'm just going to get rid of that code. We now don't need that semicolon and the let mute ret. Instead, we have a trivial constructor, which is nice and simple. Next, we just basically go through, and every time we hit an error, we deal with it. So what do we have here? We have write. So this is processing a write request that comes in from the client. We do not want to store our data here. Instead, we want to go let mute writer. So how do we get hold of our server? Self.server let's go for storage .start write with the digest. And let's await that and clear the result, and we're good. So we've got ourselves a writer. We now want to give that first chunk of data to the writer. So writer dot write block, and we're going to have to give it that whole vector because it takes that data, I believe. Although realistically, should it? It can't usefully take ownership of it, so it should probably take a borrow of a slice. Let's fix that first. Diversions. So yeah, write block at the moment consumes a vec of U8, but given that it's doing extend from slice, there's no point in it consuming it. We may as well take a U8 slice. And that's going to give us 2 errors. We've got here, we're going to need to borrow data. And here, we don't need to convert it to a vector in the test. So that's happy. And now in memory storage, we just need to fix the same things. So it's borrow of a U8 slice. And then we can just extend it from that slice. We don't need to faff about. That's hello as a byte string, and so is this. And that should have cleared up those bugs. Good. So we can go back here and we can carry on work. So we're not going to write first mixed data, we're going to write borrow first mixed data, and we're going to await the result of that write. Now, as we read from the write stream, instead of data extend from slice, it's going to be write block mersk dot data dot await. And if we've finished our writing, which is this point here, we need to compute the uploaded, digested, inserted into the map. All of this goes away because all of this is handled by... Is it? No. Okay, uploaded digest comes from writer.finish.await. So we've now completed the write. If the digest didn't match, it's an error. So that can just say inserted. We construct the write response. We don't need to do that because we've already actually inserted it into the map already. So we've done that conversion, and now we have our first actually useful error to think about. The trait send is not implemented for mutex guard block CAS server required for the cast to mumble 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 stud send. So what's happened is we've kept hold of the borrow into the server for some reason, which we shouldn't. There's no need for that to happen. So let's see if we can get that whole error spewed out for us more usefully. Right. Future cannot be sent between threads safely. Future is not send. The await occurs here. With self-server may be used later. And it's later dropped where? Right. Okay. So the issue is that we've dropped the server while we've still got hold of a writer to it. And it's basically being upset about that. Let's try to be a little bit more explicit. So we can go let server equals self.server. Wait. Nope. Self.server. Is it not self.server? Where is our self.server gives a result mutex guard. Right, so it is just self.server question mark. Then we can say server.storage. Now let's see if we can get a better error. Right, okay. So the future created by this async block is not send. Within blah, the trait send is not implemented for mutex guard. Future is not send as this value is used across an await. So it doesn't like us holding that mutex guard across an await. Let's stop using stdsync mutex. Let's use Tokyo's mutex instead. Yoink those away. And save. That's going to start all sorts of errors. That could be a Tokyo mutex instead. Now, locking needs awaiting. There is no mutex go boom because Tokyo mutexes don't do that. Here, it's not just a server, it's an async fn, which gives a mutex guard back always. And can we get the mutex guard type from Tokyo? Implicit elided lifetime here, assuming a tick static. Mumble. Indicate the anonymous lifetime. Type mismatches. Expected. Blah. Found opaque. Impulse stud future. Because that needs to be awaited. This is starting to behave. So that needs an await and not a question mark. And now this needs to be an async fn extract digest. You see, we get there eventually. Extract digest can be awaited. It's the joy of refactoring this kind of thing. So now the question is, will that now be happy because we're using a Tokyo mutex instead? And the answer is yes. Hurrah! Okay. So we've rewritten write to use our new backend. So let's rewrite read. Step 1, we need an await there. Step 2, instead of a question mark there, we need to work out what we're doing. So let reader equal self.server await storage dot start read, giving it the digest, await. Right, so that gives us an option on a reader. So we can say we can do let reader equal match all of that. None becomes that. Error return. Some reader gives back the reader. So we've now got hold of that reader. And now is where we find that I didn't actually implement the trait very well. And part of that is that realistically we need to pass to that start read function the offset that the user has asked for, the limit that they've asked for, so that that limiting can happen in the reader. So let's do that first. Actually, no. Actually, yes. Ooh. Yeah, let's do that. Okay. So start read needs an offset, and they're always I64s in the wonderful world of content addressable storage. We need a limit, which is also an I64, and that will do. Now this is obviously going to start to throw some errors, so we want to start reading at 0 and limit 0, which means that we'll get everything. And I don't think I've used that anywhere else. Nope. Okay, so back in the memory now. In this test, we're going to put 0 and 0. And in the reader, we need an offset I64 and a limit I64. And we need to fix this sending loop to do the right thing. So what can we get out of this? Well, the first thing is that we actually need to know whether or not the data is too big. So let's actually go let data equals all of that. And in fact, let's match on that. Boop. And so if there's some data, we're going to return it. And if there's no data, we're actually going to return. What can I return? I can return a not found error. No, I just want to return an OK of none, because we didn't actually throw an error at this point. The data wasn't there. So we're going to say, nope, there is no data here. Now, what we want to do is do our offset limit stuff. So let's go and steal that back from the server. So the server here says this. And in fact, we can get all of that out of there and pop it into here, because it should be good. We've got some problems with braces. What's going on? The data is match all of that. That should be the close of the match. Open, close, open, close. I'm just going to go data there because it's silly. And what have we got? We've got that, and nothing else. Right, now it's formatting properly. Okay. So data.len mismatched because I64s and U sizes. So data.len as I64. As I64. So to send, we also need a data.len as I64. We're getting somewhere. Right. Next step is to get rid of that map and that open brace, close brace, and get down to here. So we've created a sender. We've spawned the thread, which ultimately is going to be a problem if something weird happens. So why don't we see what's going on here? The trait bound std result blah option mumble is not okay. So this is not just the result that we care about, which is this read session instance. It's actually an OK sum, all of that. And that should satisfy those types, which is good. And all we need to do is deal with the stuff in here. So we need to know our current offset. And we need to work out what we're doing. So let's actually be quite clear here. Let's start being quite specific. So offset equals offset as usize. To send equals to send as usize. And the reason we want to do this is just because we're dealing with a vector. We may as well move everything back into the world of usizes. So rather than trying to send data len, we want to send to send. Our minimum is to send. And we want to send with offset plus sent to offset plus sent plus to send. All of that should now move the fetch into the right place. And so we can go back to here and we can try to finish everything. We don't need that info line. So we need to construct our thing that we are sending back. And what we're sending back here is a receiver stream, blah, blah, blah. Storage says, what I want you to give me back is anything that implements din stream that gives you a result of vex. So we're going to have to consume that to produce the read responses, which are then going to be returned from here. And we can do that in this function. So we can clear out that spawn and we can start. We can go while let sum block is reader dot next dot await. And given that we know that reader is a thing that gives us results of VEC-U8s and statuses, what we can do is we can match that block. And if it's an OK block, then we're going to do something. And if it's an error E, then we're going to send that error down the stream. Remember that the stream for readers is results read response status. So effectively, we can bubble that error straight into the receiver stream and stop. So we're going to do that. We're going to say tx.send error E await break. You know, if we've got an error fetching a block out of the storage, we're just going to stop. And finally here, we need to actually send this block through, which means that we are going to send one of these read response messages. So we can go let msg equal read response. And that, let's put that in the middle of the screen. There we go. That read response just needs some data, which is going to be the block. So in fact, let's just say data, and let's be here that we're saying data. And then we need to send that. So we're going to tx.send OK of message and await that. And then we'll go around the loop again. Let's see how badly coded this is. So no method next found for blah, 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 blah. In reality, that means that we need Tokyo streamxt. And the start read here needs to be given the offset and the limit. And we need to not have converted those. And limit doesn't need to be mutable. Has it gone boom? It hasn't. Okay. Goodness me. Is there anything I've done so far which people are confused by? My hope is not, but you know, it can happen. I'm going to move on while we play. So we now know that mutexes are async, so we've got to go async there. It's not a result mutex guard, it's a mutex guard with a tick underscore, and we don't need to do that, but we do need to await the lock. The server needs to be awaited, and at that point it's going to say, hey, we don't have a content. And that's correct. We can't just extract data in this way from the storage. We actually do need to retrieve it. And since we're trying to convert it to a directory object, we know we're going to be doing that in memory anyway. So let's get on. Let's effectively work out a way to just read all the data out of an object in the storage. And I think we could do that by adding a method to the storage trait that has a default implementation. So let's do that. So the following have default impls which are naive but work. Async fn read blob, which takes a self and a digest and returns a result Beck U8. I think that's a reasonable shape for this function. Ret is a new vector. Reader is self.start read of digest 00. Await. We should probably stick option. We could convert the none at this point into a not found error. That could be better, and we could get rid of that option from the read interface entirely. That could be better too. Shall we do that? Let's do that refactor as well. So we're going to do that, which will mean that we've got a reader at this point, or we've got an error. We're now going to, let me just stick a to-do there to shut that up while we find all the other errors. So we never have some mute reader. Either it succeeds in starting or it's going to return this error. So we can get rid of the match. We can do let mute reader is that. We get rid of that and that. So expected a bang. That's a fun noise, isn't it? What's going on here? There. That's tidied up batch read blobs a bit. There's no more errors down here, which is good. There will be some errors in memory. The first one being that start read has the wrong type. We want to return a result. So, none doesn't return OK none. It now returns error of status new of code not found. Not found. And what else have we got here? Yep, we don't need the sum here because we've definitely got the object. And one more error down here where we don't need that because the write should have succeeded. Otherwise, that's going to bubble out a not found error. What have we got now here? Right, yeah, so type inside async block not known. That's fair enough. Okay, ret. That'll shut that bit up. So we've got a reader that's working. If it was not found, we'll bubble that error out. We'll deal with the new error that's will have occurred in server when we're done. But let's finish this simple read blob, and it's going to be while let some block is reader.next.await. Question mark? No. await. Yeah. Let data equal block question mark. Ret.extend from slice borrowed data dot dot. It's a bit sad that we're going to be allocating and then freeing and allocating and freeing, but you know, we have to deal with that. That will do. And that reads the whole blob in. So now we can come back here. We can find the first error that's here, which is that there's this none sum malarkey, which just doesn't need to exist. Word match is the problem there. That's solved that problem. Now we can come back down to here. So content doesn't exist because it doesn't exist. Get digest, okay, or blah, unknown digest, blah. So what we actually want, instead of all of that, so we want the storage, and we just want to read blob of digest, question mark, no, dot await, question mark. And that will give us that data out. Self.server. Okay, so what's it upset about? It's only available in async functions, so we'll make getDir an async function. And that's now working, so we can keep going. Huzzah! Right, that question mark becomes an await. That question mark becomes an await. So this find missing blobs we can actually make more efficient, because here we are locking the server and then doing a continuous contains key. This loop is actually implemented for us by default over here in the storage trait. So let's just use that. So instead of trying to faff about, we know that we have a vector of digests because that's request.blob digests. So let's just ask the server for which ones are missing. So let's just say let missing equals self.server.storage server.await.storage.find find missing blobs. And this takes a boxed something that gives it digests back. So it's going to be a box new of request.blob digests.into iter. And if we await it and unwrap the thing, we're going to get a vector of digests back that are missing. Well, that vector of digests that are missing is exactly what we need to plug into the response. So what we can do instead of anything more complicated than that is that. And there's find missing blobs fixed. Ooh, batch update blobs. This is going to be a bit more complicated. So step 1, we await to get the instance name. Step 2, we are dealing with a batch of inserts. Each entry in requests is a request object. That request has some data, which is a vector of bytes, and a digest, which is a digest. And we need to insert that into the storage, and for everything that we've inserted, we get a result back that we need to do something about. So what's the shape of this for the storage? Let's go back across here and have a look at batch update blobs. That takes a boxed iterator of digest and vector and gives you back a vector of digest and tonic status. So tonic status is going to have to be converted into a Google gRPC status, but that should be fairly easy to do because nominally there aren't very many codes that will get returned. Let's do this. So step 1, we need the boxed iterator of digests and data. That is going to be fairly easy. It's going to be, let's go for the update is request.iter into inner dot requests dot into iter dot map. Given the request, I want the digest unwrapped and the data. So that's given us an iterator that's giving us digests and vectors. So now let's say let update result equal self.server await .storage .batch update blobs box new update .await, and we now have a vector of digest status pairs, which we need to put into the response object. We could just map those across. So if we said, if we move this let mute response malarkey down here, and what we say instead of mute, it's just its response, and the responses are the update result into iter map given a digest and a status. What do we want? Well, we need to create a batch update blobs response object whose digest is some digest and whose status is some RPC status, where the code is some, no, it's just an RPC code, but we'll get that by matching status and then message is empty and details are empty. And that should do. So the only thing that's left is RPC code blah. So I'm going to put an as I32 there. And we don't just want to match status, we want to match status.code. So code OK goes to RPC code OK. So this is update blobs. I suppose realistically we want to be able to convert any of these gRPC status codes into an RPC code. So rather than doing it like this, let's write a little helper function. I'm just going to stick it at the top level. So fn RPC code for status, which takes a code and gives back an RPC code. And these are all of the codes that exist automatically expanded for us. And then here, where was it? Not find missing blobs. Doobie-doobie-doo. Instead of match status code as I32, it's going to be RPC code for status of status.code. We don't need to borrow that, that's pointless. So we need to implement that. We'll come back to it in a moment. Let's see if we can finish this first. Mismatch types expected, a vec of blah, found a mapping iterator. That's fair. Collect that into a vector. Okay, we're getting somewhere. Let's start to do these conversions. What are the RPC codes that are valid? Let's find out. Google RPC code. Okay, cancelled, unknown, invalid argument. You know, these look remarkably similar. Let's see if we can write a little bit of How do I do macros in VS Code? Because really what I want to do is copy that lot, and then on the right hand side it's RPC, that lot. Let's just try doing that and see what happens. RPC code cancelled. RPC code unknown. I mean, in theory, I think these enums are identical. But what I don't want to do is accidentally discover that they're not exactly the same. So let's try and be explicit about this. Almost there. Right, there's that solution. Okay, moving on. Batch read blobs. We can do a similar treatment here because we already have a batch reader in our storage constructor. So to achieve that, what do we want to do? We want to wait to shut that up. And we now effectively want to construct the read request and then deal with the response. So let's do the read request first. What do we need in order to batch read? We need a boxed iterator that produces digests. We have request.digests, which is a vector of digests. So what we ought to be able to do is go let let's say batch read equals self.server await storage batch read blobs with a box new of request.digests.into_iter await, and now what we have is a vector of digests to results of data or error, and we can convert that into our batch read blobs response. So we go let response equals batch read blobs response, where responses is batch read.into_iter map. Given a digest and a value, which we know is a result, go and collect that into what we want. So let's just stick a to do there to allow everything to settle for a moment. What do we want to do? Well, we want to construct a batch read blobs response object. Copy, paste, and the rules here go that the digest is some digest. The data is going to either be that the value is successful or we had a bad status. So let's go here and go let data equals, and let's do let data comma code equals match value. So okay, data gives us back data, and we want an RPC code, so it's going to be RPC code okay. error S for tonic status gives us back an empty vector and RPC code for status s.code. So we've now got data and code, so we can just pass data there. And let's grab the compressor. And status is going to be some RPC status, where the code is code, the message is empty, and the details are empty. And then we can remove all of that. And our only difficulty here is our batch size. So batch read blobs should probably take a maximum batch size so that we can defer this error to that operation. So off we go. Let's do that. We don't need any of that because the not found will work automatically through the batch read. Okay, batch read blobs. At the moment takes a set of blobs and it's going to take a max batch bytes, which actually we can deal with this entirely on this side because either the request set fits in the batch size or it doesn't. So let's do this before we even execute the read. And we can do that here. We can do let total bytes is request dot digests dot map or dot iter dot map. Given a borrowed digest, we're going to extract its size bytes. So that's going to be d dot size bytes. And we are going to sum all of those. If total, not total read, but total bytes is greater than the max batch, you've requested too much data. So we can actually handle that up front. There's no need to do the reads and then go, oh, no, we need to stop halfway through because everything's gone wrong. Convert that code. And what have we got here? Some type inside async block must be known in this context. Size bytes is I64, so some I64s, please. That's settled all of that down. And now we're doing get tree. Server await. So get tree needs to retrieve a directory object. This does a contains key, but we don't care about that. We can just retrieve it directly. So we can do. In fact, let's be almost directly the same here. So we're going to await. We're going to need the storage, and we have in our storage API a contains method. So we'll call that, and we'll need to await it and unwrap it. So that now should clear the errors from there. Get_dir will need awaiting. And get_dir here will need awaiting. And that's get tree fixed. So the play cache, again, needs to be converted to async mutexes. Let's do that. And let's begin. So, validate result takes a CAS server and a result and starts to faff about. Instead of taking a CAS server here, let's take a borrow. Should I just say a borrow din storage backend? Yeah, why not? And we don't need content here. We need contains and await. Now, of course, that could return a result object. So we're going to stick that on that, and we're going to stick a result on that. Await is only allowed inside async functions. Cannot find trait storage backend, import it. Question mark operator can only be used in an async function that returns a result. It's bool or a status. So if it doesn't contain it, then we're going to say false. That's okay, false. It's an odd way of doing it, but we might tidy this up later. So, content get tree map arc clone. This is not what we want to say. We want to say, did we still call it server, by the way? We did. Should I continue to call it server? No, let's call it storage, because that'll make the errors a little easier to find. So instead of server.content.get tree, it's going to be storage read blob of the tree digest await mismatch types expected a struct vector. If let some else tree didn't exist, false. Yeah, so realistically we can now start to tidy up some of these things, because we don't need quite as many messy bits. So that's going to be a borrow of a tree. We don't need any of that. Okay, let's continue. So, for every file node, we just check whether it contains it, and if it doesn't contain it, we return false. So for every file node, we're just going to go if not storage.contains digest wait return okay false. We are decoding tree. Is that an easier way to tell it to decode? Yes, okay. And then again, we have that same structure here. So it's storage.contains digest a question mark, question mark gives an okay false. The tree didn't decode. Now we're checking the other one. So if not digest.hash is empty and storage.contains digest await return false. And again here, storage contains digest await. Okay, false. Otherwise, we've got all the way to the end, and we succeeded in validating. Whew. Right, get action result. The server just needs awaiting. And then we have a bunch of stuff here. So we have a server. We've got the action cache in the server. We just need to be able to retrieve the content for that. So it's going to be server.storage.read blob of that digest, and there's no map on the end. We need to await that, and if we failed to get it, then we're returning a not found. So realistically, we can just stick a question mark on the end there. And let result data equal that, and get rid of that whole thing, because we now propagate out the errors properly. I think that, let's see what's going on. So this close brace and this close brace. So if we get rid of all of that and we get rid of that, what have I messed up? I need a semicolon there. There we go. Right, that's tidy now. And then self-colon validate result. Well, that needs an await. And it doesn't take a server, it takes server.storage. The trait bound stood box blah storage backend is not satisfied. I probably need an impl, don't I? Let's see. Do I need an impl din storage backend for box din storage backend? It's going to be a async trait, and it's going to be async fn start. Actually, do you think this will work? Expected a trait, found a type. So it could just be impl storage backend. Missing members are these three. self.as_ref.startWrite digest.await. That's all looking good. Self.as_ref start read digest offset limit wait, and self.as_ref contains digest await. And that's got rid of that problem with box. So we're down to hopefully very close to the end now. So await the server. We want to insert this arbitrary chunk of data into the action cache. So we're inserting a blob into there. Let's do an await there, because then that'll get rid of that error. So our last error is needing to be able to write that result data into the CAS. Let's add an async fn for writing. So async fn write blob self digest data. Now what have we got data wise here? We're just going to say I have some bytes, and I'm going to get a result digest back out the other side. So we're going to start a write with the digest. We are going to write a block. which is that data. And we are going to finish and return whatever comes out of there. So that's a trivial write blob method, which now means that we can do self.server.await.storage.write blob. We don't need to clone the result digest because we need to borrow it. And we don't need to convert that. We need to borrow it as well. We are getting very close. We've got another error here. Cannot borrow reader as mutable. It's not declared as mutable. That's fair. That should be mute. And we've got one more error in here. Cannot assign twice to immutable limit. I'd like to be able to mutate limit, please. Unused result that must be used. I'm going to be very cheeky and assume that I can always write. And down here, what have we got? Unused result of write blob. Stick a question mark on it. Question mark can only be done by await. And where's our last warning? It's all the way up at the top here, and it's that we're not using min here anymore. Well, that's terrifying. It's compiled. But do we think it will actually work? That is a very good question. Cargo run. Serve. We're running a server on port 5000. Let's Bazel our way into a quick test. I mean, it didn't throw any errors at us. And this certainly looks like we've done a bunch of operations. And that retrieved actions and data from the cache. Okay, what we have now is we've made our server generic over any storage backend. That's pretty cool. I'm quite pleased with that. Should we make a nice commit? Let's do that. Here we go. Status. Let's have a look at what we've done to storage. So what we did here was we cleaned up write block, we made start read more useful, we added a read blob and a write blob, tidied up the things that implemented against that, and fixed the one test that we have. We should probably write some tests for those read blob and write blob methods before we get much further. And in fact, we should run cargo test and verify that we've not cocked up any of the test cases I had. Good. Let's add some test cases for read blob and write blob, and then we'll commit the storage changes. So, async fn write blob. So memory is memory storage instantiate. What I'm going to do is try to do a write blob that does all the right things. Oh, that reminds me actually. One thing we didn't check in write blob is that the digest was correct. Let's add that check here. So we can go let written is that. If written does not equal digest, error status new code in data loss, invalid argument, data does not match digest. Else, okay, written. We'll need a semicolon there. We'll need to borrow written and compare it to digest. Okay, so that's got that correct. So let's get on here. So we want to write hello. Right, let's do read blob first, because then I can copy the all the setup code from here. Read data equals memory read blob. Hello digest. Await. Assert equality on read data and that. So if read, so we create a writer, do a write block, create a finish the writer. But if read blob works, we should still get that to come out right. So let's confirm that's good. And now let's do write blob. And what we'll do is we'll just take this as a whole because we're confident that read blob works. So instead of doing that write operation, we'll just go memory write blob. Hello digest. Be hello. Wait. And assuming that works, we've got trivial tests. It's not called read blob. This one is verifying that write blob works. Good. Okay. Various cleanups, new methods, etc. So we have now port server to use new storage backend trait. That's all pushed. All right. Next thing that I'd quite like is for the server to have some persistent storage. Be really nice if we could have a file system based store and have our CAS use that. So let's work out how we can do that. Step one, we probably want some configuration to be able to do that. So let's see, serve, instead of being given nothing, can be given some server data. And we can derive parser and debug on that and do struct server data. And clap long. What are we going to call it? We're going to call it base is an option path buff. So if we pass a base in, then we're going to set it to be a file system. Otherwise, we're going to set it to be memory. So we have an error, and the error is let's serve, yeah, right, serve data. And we call serve and pass in the serve data dot base dot as dref will do. And what we actually want to pass here is going to be base, which will be an option path. Assuming all the errors go away, then we're doing well. It's an option borrow path, isn't it? Unused variable base, that's good. Serve is going to take an instance name and it's going to take the base. Our server, if you will excuse me for my burpy burp, we'll go base, option, borrow path. And here's where it gets fun. Match base. None will give us a memory storage. Some path will give us to do. I can't find path in the scope. Import it. And it's unused. Right. So we've set up the command line for all of that. So now let's write a file system storage. So we had pubmod memory. Let's have pubmod disk. That's going to complain. Create the module disk. Right. On disk storage backend. Pub struct on disk storage. What's going to be inside our disk storage? Well, we're going to have a base path. So we'll say base is going to be a path buff because that's what we need. Import on disk storage. Instantiate is going to give you back a box din storage backend. And again, I'll just stick a to do in there for now. This is all good. Instantiate probably needs to actually take the base, which will be a path, which we're also going to have to import. And now the server, instead of this to do here, could say, actually, that's going to be an on disk storage instantiated with path. Instantiate is private, so let's make that public. We're just slowly digging through, getting to the point that things are good. So we don't need to touch the server now. We don't need to touch that main casplay. I'll leave memory up because we might want it. And let's add our impl storage backend for on disk storage, which will be an async trait. Give me the missing members. And that now, getting better, can't find async trait, that's fine, let's import it. Let's qualify digest. Let's qualify read session instance. And we're getting somewhere. So coming out of here is going to be a box new of self, where base is base.to path buff as box din storage backend. So that gets us the instantiation. We might want to be clever about this and have it make the directory there and then, but this is good enough for now. Actually, no, let's do that. So let base equal base.to path buff. Then we can just stick base there. We want to create the directory if it doesn't already exist. So that's the equivalent of mkdir-p. So is that going to be fs make blah, use std fs fs create all, there we go, of base. This could error out, so we're going to stick a result on that. Can we return results from the server? It's an anyhow result. Yes, we can. So I'm going to stick a question mark on that. We're going to take result. It's going to be an IO result, I think, is what comes out of this. Yes. And you're going to complain that we don't know what IO is, but that's okay. That's .io. So we've created that base directory. Now we need an OK around that whole thing. And I'm not going to try and be clever here. We're just going to put files in that directory. I'm not going to try and do any more than that. So when we try to start a write, we will open a file. We'll start to do writes into it. When we complete the write, we'll rename the file so that it's in the correct place. When we start to read, we'll just open that file and return a stream that can read from it. I've brought stdfs and stdio in. Does Tokyo have a create dir all, do we think? If I just stick, literally, I just stick Tokyo in there instead. And I stick an await on there. Are we done? Not quite. We'll now need that to be an async function. And I think at that point, we're going to have problems. So I'm going to get rid of those imports. I'm going to stick stud there, and I'm going to stick stud there. And my reasoning for this is that I don't need it to be asynchronous at this point, but we are going to end up using Tokyo file and Tokyo IO down here. Let's write contains first. Actually, let's write fn path 4, which takes a borrow of self and a digest and gives you back a path buff. And that is going to be base.join self.base.join format. Let's just use dashes, why not? Digest.hash, digest.size bytes. So that should be that. And now in contains, we can go, let full path is self.path for digest. And what we want here, and I'm just going to unqualify that because I'd rather have that sensible. The return type here is going to be whether or not that file exists. And we know whether or not the file exists by doing an IO operation. Now, if the IO operation fails, we'll need to convert that error before we can publish it. So it's going to be fs metadata for full path await, and you're going to complain that fs doesn't exist, and that's going to be Tokyo fs. Now that returns a, if I'm correct, yeah, it returns a Tokyo IO result of the metadata. So we need to map errors to be status, which is going to be a tonic status new with a code. What code do we think will be most sensible for I had an IO problem? Let's go with just not found. Code not found. Not found. Question mark. No. If it's not found, we want to turn it into a success with false, not an error, because this is a contains check. So we're going to match this and OK meta, well, OK anything means that this thing exists, and we'll return OK true. Error E. If E dot kind is error kind not found, goes to OK false, and any other error goes to error status new code unknown message format and we'll format up an error code for that. Unresolved use of code, it's going to be a tonic code because we've got a tonic status. So we've implemented contains. Now let's do start read. So let bool path equals self.path for digest. We now need to open that file. So let mute file equals fs file open or path await. And again, we've got an IO error. So we are going to map error E question mark. And that map error is going to say match E dot kind error kind not found becomes status new code not found. Not found. Anything else becomes status new code unknown error. That opens the file for us. Now we need to seek init to the offset that we've been given. So seeking which is going to be a seek from start offset as U64 await. We're calling map error an awful lot now. Do we want a function for that? Let's do that. fn map IO error, which is going to take an IO error. I'm guessing, unless I'm mad, that this is actually a stud IO error and gives back a status. And we're going to match dot kind, and we're going to say error kind not found goes to So that function will do that conversion for us. And now instead of this, I can just go map error. Map IO error. We can do a wait, map IO error. So that seeks us to the offset that we want, and then we just want to read chunks until we've read everything, and we have to do the stream malarkey. So let's do that. Let txrx equals mpsc channel. So yeah, I needed a reminder of how we do it. It's just mpsc channel. And again, 4 blocks seems reasonable. That's going to whine. It doesn't know where mpsc is. It's going to be Tokyo. Our return is going to be an OK of a receiver stream new of Rx as that. And that whole lot gets pinned. Read session stream needs to be imported. Non-primitive cast. Tokyo wrappers receiver stream. I know what I'm doing. Helps if you box the box. There we go. Finally, we need to actually send the data. So it's going to be a Tokyo spawn. Async move. Let total red equals 0. While total red. No, I can just. Limit is how many bytes to read. So what we care about here is knowing that the limit, if the limit is 0, what do we care? What do we care? Let's compute it, just because it's a good idea. Let flen equal file dot metadata await. So we've got the file length now. So let toRead equal flen minus offset as U64. So that's now. Oh, if the offset is bad, yeah, we need to do all the checks. So let's do this properly. If flen is less than offset as U64, return invalid argument, offset out of range. Okay. The limit is now needing to be set up. So if limit is 0, if limit is 0, limit is flen as I64. Then we compute how much we want to send. To send is the minimum of the amount of data we want to send minus the offset. So len as I64 minus offset, and the limit. That's correct, and that's now going to complain it doesn't know what min is. Or is it? Did I actually manage to import min properly? No. The trait bound storage on disk storage backend is not satisfied. I've got a mess here, that's why. There we go. Cannot find min. Well, that's still come with min. We're getting better. Okay. Essentially, we want to do this chunk of stuff here, except we need to read the data. So the final thing we want to do is get that as a usize, and we're good. So we have our channel, we've done our seek, we have our total read, and we basically want to go, well, let's call that sent actually, because then the code looks pretty similar. While sent is less than to send, we need to read a block. Let mute buffer equal vec with capacity, I don't know, let's have block size. Const block size usize is let's do a megabyte at a time. That'll do for now. So we've got our vector, we need to read data into it. So the way that we do that is we go let read size equals file dot read that wait map error map IO error. I probably want to match that. Whee, what happened? Don't know. Okay, size goes to size, error. E goes to tx.send, error E, await, unwrap, and break. How close to something are we? No method named read. Let's get Tokyo IO async read. And what's the method on this? So it takes a buffer, pulls some bytes into the buffer, returning how many bytes were read, provides no guarantee. If the return value is OKN, it must be guaranteed that 0 is less than or equal to n is less than or equal to buffer.len. It is your responsibility to ensure that the buffer is initialized before. Okay, fine. Let's do it that way instead. I don't like doing this, but it'll do for now. So we've got a buffer, we've read some data into it. We've got a size out. Buffer dot resize, read size 0, doesn't matter because we're going to be shrinking it. And now we want to send that over, so it's going to be tx.send, okay, buffer, await, unwrap, tx, And that's then going to be sent plus equals read size. How much of a horrid mess is that? Pretty good. Okay, what's going on? No method next for that. We need Tokyo StreamExt to make that work. And that's interesting. What happened? Why did it add all of these default implementations into our code? I must have mistyped at some point. We don't need any of that. Right, okay, that's the read implementation done. Let's do the write implementation. The write implementation needs us to have a write session type. So in memory, we had this simple memory storage writer. We need the equivalent in our thing here. So let's have a... do I need it to be pub? No. Struct on disk storage writer. That's going to need a let's say file, which will be a file from Tokyo FS. It's going to have an ongoing digest. Let's see if we can find that. Let's go to the base digest crate. What have we got? Now, so we had the SHA-256 crate that we were using, didn't we? So the SHA-256 crate has a digest function that digests a string, a digest bytes, that digests bytes, and a digest bytes. So this is just a simple digest. So we'll end up using digest file to check when we're done. Okay, so we don't need that. We probably just need a... We'll have a digest because it... Is it right to check in here? No, because we just returned the digest that was written. What we need is how much data has been written. So that's going to be an I64. Let's make it let's be better than that. Let's make it a U64 for now, and we'll worry about improving that later. And we need the name that we need to rename the file to. So we'll say target, which is a path buff. Right, now we need to implement the async trait for storings. This is the write session trait. Let's yoink that and write that for on disk storage writer. Cannot find write session in scope. Import it. Implement the missing members. Right, so write block is really simple. That's going to be file.write all of the block that we've been given. Map in map.io error. Question mark. Self.size. Self.size plus equals block.len as U64. Okay. Yeah, unnecessary parentheses. That's writing the data out to the file. When we finish, we need to close the file, which will hopefully flush it. So actually, Let's stick that behind an option so that when we finish, we can take it. So that's going to be self.file.unwrap. So we're finishing. Step 1, we need to close the file. So we're going to go let mute file equals self.file.take. Unwrap. File dot. Is there a close? Does Tokyo let us do an async close on a file? Tokyo IO. Right. Tokyo file. I don't think that there's a Tokyo FS file close. I think we just get to drop it. So let's flush the file. And then let's drop the file. So that will complete the close operation. We then want to digest the file. We don't just have a target there. We need a writing as well, because we now need to digest the file that we've been writing in order to confirm its digest. So we're going to go let written equals digest. Hash is digest file of borrow self.rating dot map error map IO error question mark comma size bytes is self.size as I64. And that's going to complain about a number of things. That should be a colon. Mismatched types, blah, blah, blah. Yep, that's fine. We're going to end up returning OK written, but not until we've renamed this file into place. And that's going to be fs rename from self.writing to self.target. Wait. Right. Cannot move out of self.file.as mute. Okay, so that's implemented the write session. So now all we need to do to start a write is get that going. Okay, we need a temporary file that we are going to start writing to, and then we can move on. So does Tokyo FS have a temporary file? There's libcmctemp. I'm going to guess no. We'll derive it from the digest. We have path4, which gives us that, and we can just have fn temp path4. And I'm going to just be cheeky and go, I want the same thing here, except I'm going to stick a .temp on the end. And okay, so to start a write, what do we need to do? We need to create our on-disk storage writer. So we're going to go let file equal fs file create. Okay, let written equals self dot temp path4 digest. Let target equals self dot path4 digest. So we're going to create written, await, map error. That gets us our Tokyo FS file for the digest. And now we can say, super write session instance, don't like that. Qualified path, please. Okay. Yeah. So it's going to be a that.into, and that's going to be a box new of on disk storage writer of that stuff as box din write session stream, and that stuff is going to have, so there's file size, writing, and target. File sum, file size 0, writing, and target. So we've got box new on disk storage writer as box din write session. I'm just going to get the whole error message out. Oh, I'm missing an angle bracket there. Expected type found alias write session stream. Remind me of the shape of this as box write session stream. That all looks sane. And it's compiled. I mean, this is the terrifying thing. So, cargo run serve base temp CAS data. What do we think will happen if I run the Bazel thing against it? It ran, but did it actually write anything? There's a whole bunch of files there. So if I run Bazel again, it's ended up redoing things. So that's not ideal. So something bad has happened. What's happened? Put some blank lines in, and then let's rerun Bazel. So had a capabilities request, we had some get action results, we found a result, stood out was missing, so we failed. Aha! The empty digest. Of course. You know how we inserted the empty digest automatically in the whatchamacallit? We should do the same when we create an on-disk storage. So we create that path, and then all we need to do is create an empty file with the right digest. What's the empty digest? The empty digest is this. So let's yoink that out. Let's take a copy. So we're going to go drop stud fs file create Self.path for a digest. Oh no, we can just do base.join that -0. Does it make more sense to return the empty digest as a default thing in the main program? It may do, except there are any number of places where you could request it. So it might be inside an action result. It might be that you've requested it with a byte stream read. It might be that it's in a find missing blobs. It might be that it's in a batch read blobs. So generally speaking, it's just better if the storage understands what an empty blob is. So we need to do that. What have I now done? So that creates that empty blob during the startup. One thing that is not going to be in the on-disk data is the action mapping. So this is going to rerun to some extent because the actions don't exist. So yeah, update action result happened a number of times. And now let's run it again, and it's quick. So we fixed that problem, but our action cache doesn't store to disk. But there's our on-disk CAS data, and that's clearly working. Could we do this via a default in the trait? I could complicate everything in the trait to do it, yes. It just seems a lot easier to insert the empty thing. Remote CASs will automatically have it. The memory cache has it. The on-disk cache has it. It's not really worth worrying about. We could start to try and short-circuit things, but it just seems a bit daft. So that's now there. We have all of those files on disk, and we know that they're being returned to Bazel. What we can do as well is, if I get us another entry into casplay, we can do our usual cargo run upload of that data. Instance that. Try to add to bear. Have I stopped the server? No, the server is still running. It's endpoint, not instance, of course it is. So this is now uploading that blog, which is, as we can remember, a few hundred megabytes, and it's doing it via batches, which, again, if you recall, we had all of those generically implemented, and it's uploaded all of that. And so CAS data, if we now du that, is that 100 odd megabytes, and if we try and upload it again, and the local stuff basically should result in no change to that data. Good. And now let's do an ls on that. And that proves that we can retrieve all those objects back. That get tree works, and so on. I think that is success for whatever value of success we need for an on-disk storage. The thing that's missing is that the action cache isn't on disk, but we can worry about that in a bit. So let's see where we are. So we've edited storage in order to add mod disk. So let's git add that and that. Storage, add an on disk storage. And then this is enabling on disk storage versus memory storage. That's 2 hours worth of effort. I'm not going to do the... I keep saying I'm not going to do... So to do the action cache, we'd need to write that async trait again, and we'd need to write the 2 implementations of it. Or I could add action cache mapping to the storage backend. Which will it be? I think it needs to be a separate trait if we're going to do this. So I think that's more typing than I want to do this evening. As a result, I think I'm going to leave it there for tonight. Thank you very much, everyone. I might add action cache as a generic backend at some point during the week. And if you have ideas for what you think we should do with casplay next weekend, then say. But if no one else has any particular ideas, then what I'm going to suggest we do is we add a -- remote variant to the storage to access a remote CAS and a remote action cache instead. And that way we can try having casplay back onto BuildGrid, for example, and verify that that all works as well. Thanks for watching. Bye for now.